Hello everyone, I am Suchita Moril. Welcome you all in the video lecture on the topic Inverse J transform by power series method. J transform is defined as J transform of f of n equal to summation n equal to minus infinity to infinity f of n j to the power minus n, its value equal to capital F of j, and J inverse of capital F of z equal to f of n. Z transform of 1 and u of n is z upon z minus 1, then z inverse of z upon z minus 1, its value equal to 1 or u of n. Now, inverse Z transform we can find out by different four methods: partial fraction method, convolution theorem, residue method, and power series method. In this video, we are going to discuss this fourth method, power series method. Now, in this power series method, we use infinite geometric series or binomial expansion with negative power or divide numerator by denominator. If the f of z is the ratio of two polynomials, then take inverse z transform of each term in the quotient. These methods will be used when the region of convergence is given by coefficients of j to the power minus 1, j to the power minus 2, and so on. That means f1, f2, f3 is the sequence of fn. Now we discuss the problems on this. Example number 1. Here find z inverse of 3z square plus 4z upon this denominator term. Here capital mod of z, its value is greater than 1 by power series method. Now here consider this capital F of z value. Use equation number 1. Now here we divide the numerator by denominator. Now this is rough work is here. We divide the terms 3z square plus 4z by z square minus z plus 1. Now here quotient is 3. We write down the remaining term as remainder as 7z minus of 3. Again we divide the terms 7 by z, then we get these terms. Remainder is 4 minus 7 by z. Again we write down here 4 by z square term. We get the remainder minus 3 by z minus 4 by z square. Again we divide the terms. In this way we divide the terms. Now after dividing the terms we write down this as 3. This is the quotient value 3 and remainder is 7z minus 3 upon denominator term. Now again we consider this, that means the second value is 7 by z, 3 as it is, then 7 by z into remainder is 4 minus 7 by z upon denominator term. Now 3 as it is, 7 by z as it is. Now third value of the quotient is 4 by z square, and this is the remainder value upon denominator. In this way we write down this series. Now here we write down this f of n value as here z transform of f of n equal to, this is the definition. If we expand the terms f naught z to z naught, that means n equal to 0 here, we get this term. N equal to 1, we get this term. N equal to 2, we get this term. Therefore, fn, we write down this is the first term 3, that means coefficient of z to the power 0 in the equation number 2 here. 3, then 7, 4, minus of 3, minus 7. We write down all these values here. This is the required answer. That means z inverse of capital F of z. That means Fn value. Now another example. Here find z inverse of z cube upon z minus 2 whole cube. We can solve this by different method, that means residue method also, by partial fraction also. But here mention that use power series method, and here mod of j greater than 2. Here mod of z which is greater than 2, that means region of convergence we have is given here. We adjust this term as 2 by mod of z, its value is less than 1. For this we take here z cube common from the numerator, and then write down the term as 1 minus 2 by z. we adjust these 2 by z here and then we easily expand by using binomial with negative index. Therefore, we write down this value in the numerator with negative index and expand by using binomial. This is the expansion of 1 minus x to the power minus 3. 1 into 2 upon 2 factorial, then plus 3 into 2 upon 2 factorial into x, and here this constant value into x square and so on. Here this is the nth term. Now this x is replaced by 2 by z. Therefore here 2 by z, here 2 by z whole square, and this is the nth term. Now, coefficient of this fn value means coefficient of z to the power minus of n. For this, we write down this in the 2 upon z to the power minus 1 terms. And then we write down the coefficient of z to the power minus n, that means n plus 1, n plus 2 upon 2 factorial into 2 to the power n. This is the coefficient of z to the power minus n, and we get this result. If we solve by residue method or partial fraction method, we get same answer. In this way, we solve the problems by binomial expansion method. Now third problem, find z inverse of log of z upon z plus 1. Now we solve this by power series method. Now here by substituting z equal to 1 by y, therefore we substitute here values, simplify the terms, and then this minus log of 1 plus y, that means this value is log of 1 plus y to the power minus 1, we write down in this form. Now expand by using binomial here, y minus y square by 2 plus y cube by 3 and so on. Substitute the value of y, that means in terms of z. And this is the summation n equal to 1 to infinity minus here alternate plus minus sign, therefore minus 1 to the power n, then z to the power minus n upon n value, and fn equal to minus 1 to the power n upon n, and this value when n is greater or equal to 1, we can write down this in another form as when n equal to 0 its value 0, and when n greater or equal to 1 its value 1. This minus 1 to the power n upon n. In this way, we apply power series method for finding inverse Z transform. Thank you.